Okay, so in this problem we're asked to evaluate the expression sine inverse of cosine 7 pi over 6. For these, the first step to do is to ask yourself 7 pi over 6. Is that a ratio of sides for a triangle, or is it an angle? Well, have you ever seen a triangle that has a 7 pi on a side of it? Maybe, but not very often. So the 7 pi over 6 should be an angle given in radians. Really it is, because you always take a trig function of an angle, and 7 pi over 6 is your angle given in radians. So now we're going to draw that angle on your coordinate plane. So here's our coordinate plane, 7 pi over 6. We're dealing with radians here. Let's see, here's your 0 radians, same as 0 degrees. Here's your 90 degrees, that's your pi over 2 radians. If we wrote that with a denominator of 6, well, 2 times 3 is 6, 3 times pi, that's 3 pi over 6. We have 7 pi over 6, so we need to keep going. Here is your pi radians. Well, pi is the same as 6 pi's over 6. Agree with that? 6 over 6 is 1. That's the same as 6 pi over 6. But we have 7 pi over 6, so we need to go all the way around to 6 pi over 6 and then a little bit more into our third quadrant for the 7 pi over 6 angle. So this angle right here is 7 pi over 6 radians. At this point, once we've sketched our angle, we're going to make a triangle. Again, we're always going to make the triangle with your x-axis. Don't go over here to the y. Go up straight up to the x to make your right triangle. We've got 7 pi over 6. What kind of triangle do we have? Well, 7/6 has been simplified, and if your fraction is simplified, anything pi over 6 is going to be a 30-degree reference angle. So our angle right here in our third quadrant is 30 degrees. Our reference angle is 30. So now we'll have a 30, 60, 90 triangle. Across from your 30 is your 1. Across from your 90 is your 2. Across from your 60 is your square root of 3 side for your 30, 60, 90 triangle. We've labeled it. We're in the third quadrant, and we're really ready to start with cosine of 7 pi over 6. So cosine of 7 pi over 6, cosine is your adjacent divided by hypotenuse. Here's your angle. Adjacent to this angle is your root 3. Square root of 3 over your hypotenuse for this triangle is a 2. Are we done? No, because we're in the third quadrant. That has to make some sort of difference at least. And it does, because we have to decide whether cosine of 7 pi over 6 is positive or negative. How do we do that? A couple ways. Probably the way that most people do is to remember a silly sentence. So the silly sentence is, all students take... What do all students take? All students take classes. I know that some teachers say all students take calculus. That's not true. All students don't take calculus, but all students do take classes. So let's use this phrase. What does this silly sentence mean? All means that all your trig functions are positive. Sine, cosine, tangent, all the reciprocals are all positive when your angle's in the first quadrant. In the second quadrant, S stands for sine. So sine and cosecant, the reciprocal of sine, are both positive and everything else is negative. So tangent's negative, cosine's negative, cotangent is negative, secant is negative in your second quadrant. In the third quadrant, T, what do you think that stands for? Probably tangent, which means that tangent and its reciprocal, cotangent, are both positive, and all your other trig functions are negative here in the third quadrant. C stands for cosine, so cosine and its reciprocal of secant are both positive. Everything else is negative in the fourth quadrant. So coming back to our problem, we're in the third quadrant for our triangle. Third quadrant, t, tangent and cotangent are positive, which means that cosine is going to be negative in our third quadrant. Another way to think about it is on this triangle, hypotenuse is always a distance. Think of it as a length, always positive. But here, your x distance is negative. Your y is also happens to be negative, but a negative x divided by a positive hypotenuse gives you a negative root 3 over 2. Okay, so far so good. We figured out what cosine of 7 pi over 6 was. We got that it was equal to a negative root 3 over 2, which means way back at the start, cosine of 7 pi over 6 is equal to the negative root 3 over 2. So now we've got sine inverse of, we're not going to write 7 pi over 6 anymore, we're going to write what cosine of 7 pi over 6 is. It is a negative root 3 over 2. So now I have sine inverse of negative root 3 over 2. Depending on your textbook or your teacher, you might see instead of sine inverse, you might see it labeled as arc sine of negative root 3 over 2. They mean the same thing. Arc sine and inverse sine, two different names for the same thing. Why do we have a different name for it? Well, this -1 for inverse, this -1 here means inverse. If you have something like a 2 there instead, it means square. And square and inverse are different, so bear with it. There's two different names for it. Either one done the same way at this next step. So sine inverse of negative root 3 over 2. Okay, pause. We did the inside. We still have more to do. Basically ask yourself the same question we started with. Negative root 3 over 2. Is that a ratio of sides for a triangle, or is it an angle? Well, negative root 3 over 2, that's definitely sides of a triangle, and you always take an inverse trig function of a ratio. So negative root 3 over 2 is going to be a ratio of sides. Also note that you've really never seen an angle with a negative root 3 over 2, not to say you couldn't, but it's highly unusual. And you have seen triangles with sides of negative root 3 over 2. So we're going to draw another triangle. It's almost never going to be the same as this first triangle. So we're going to sketch a new one. Draw your coordinate plane. We've got sine inverse of negative root 3 over 2. Now let's notice. That's capital, uppercase. That means we're dealing with the principal values for inverse sine, where if we treat inverse sine as a function, really you're only dealing with principal values, but to be more general and even more specific, I guess at the same time, capital means you're only dealing with principal values, and when you're dealing with principal values, you won't have anything to do with the third quadrant for any of it. Your angle won't pass through the third quadrant, you won't make your triangle in the third quadrant. Why? That's more than I want to deal with in this video, but basically capital, we were never dealing with the third quadrant at all. So, sine. Where is sine negative? Well, all students, sine and cosine are positive here, all of them are positive. Tangent's positive here, and your sine's going to be negative. Also in the third quadrant, cosine's positive, your sine's going to be negative in both the third and the fourth quadrants, except we just said you're never dealing with the third quadrant when we're dealing with principal values, so we're going to make our triangle in the one place where we have sine still negative, which is in your fourth quadrant, and we're again going to make your triangle with the x-axis. Don't make it with the y-axis ever. So, we said this negative root 3 over 2 was a ratio of sides. Here's your angle. That's actually the angle we're trying to find as the answer to the question. So arc sine of negative root 3 over 2 means that sine of some angle, I'm going to write this down, this means that sine of some angle theta is equal to a negative root 3 over 2. So we decide we're in the fourth quadrant, and sine of this angle, theta, is a negative root 3 over 2. Sine is your opposite over your hypotenuse. Your opposite here is root 3. Your hypotenuse is 2. Yes, you could put a negative on your root 3 because we're going down into the negative y values to show it's negative. You don't need to though, because the point of drawing this triangle was to decide what is this angle here. Well, you've got a 30, 60, 90 triangle again. Your theta here is across from the root 3, and when you're across from your root 3 in any 30, 60, 90 triangle, your theta is going to be 60 degrees. Are we done? Not quite. First of all, remember that you're here in the fourth quadrant and positive 60 degrees is here in the first, so we're really going into the negatives, so theta is a negative 60 degrees. You might ask, well, why don't we name it like this? That'd be positive 300 degrees. Aren't those coterminal angles? Well, yes, they are coterminal angles, but remember, principal values don't deal anything with the third quadrant. When you sketch your angle, you don't even go through the third quadrant for principal values, so we're not going to use the 300 here. We are going to use negative 60 degrees. You think, yes, I'm finished, but then you're not, because what do we start with? We started with 7 pi over 6. That's radians. That's degrees. We can't start out in radians and finish in degrees. That'd be strange. So we need to change this negative 60 degrees into radians. Well, it is negative. Your radians are still going to be negative. But how do you remember what it is? 2 ways. One is to take 60 divided by 180, because 180 is your 1 pi. 60 divided by 180 is 1/3. It's going to be a pi over 3. So there your answer is negative pi over 3 overall. But another way to remember it is just through memory. If you ever have a 60-degree angle, it's always going to be a pi over 3. If you ever have a pi over 6, it's a 30-degree angle. And if you ever have a pi over 4, it's 45-degree reference angle. So overall, our answer is a negative pi over 3. And sine inverse of cosine of 7 pi over 6 equals negative pi over 3. You can check your answer. You can check your answer by grabbing a calculator. First of all, since we started in radians, make sure that you put your calculator into radian mode if it's not there already. Graphing calculators mostly default to radian mode. Smaller calculators, simpler ones, usually default to degree mode. And type it in exactly how it looks. Sine inverse, usually it's a second sine. Sine inverse of cosine 7 pi over 6. You type that in, you get a decimal. I got, when I typed it in, a negative 1.04 something. And then type in your answer. Your answer is a negative pi over 3. Negative pi divided by 3. Oh, what do you know? I got the same decimal, negative 1.04 and a bunch more decimals. It's really going to be an irrational number, goes on forever. We got the same decimal both ways. That answer is correct. Please feel free to share this video with anyone you think would be interested. And if you like it, I might make more. Take care.